So the scientific method. The scientific method is kind of a nebulous thing because it can be described in different ways, but it's a framework for gaining and organizing knowledge. And it does fall in with that scientific approach to problem solving. So it's fine to gather information, but then we also need to be able to organize it in order to make sense of it. Science is a plan of action. Okay, it's not just sitting around, there's action involved. We're going to have a procedure for processing and understanding the types of information that we gather. And another interesting thing about science is that we are always challenging our current beliefs. And so skeptics are good in science. And that's where progress is made, because people say, well, yeah, that looks like it's been, your idea there is correct, but what if this, or what if that, or let's try this a different way and see if it still works. They ask questions, and they do more experiments to gain knowledge. So when someone does an experiment and says, oh, this is how this is, and you can do it, one of the things that we have trouble with, they come out and they say, well, oatmeal does this and it lowers your cholesterol and it's this miracle thing, and then they come out with something else. The problem with that is we're experimenting on humans essentially, and yet we can't experiment on humans and control all the variables. And so that's one of the reasons I'm not into like the more biology part, is there's too many variables to control. In science, what's nice is you can control things because it's inanimate stuff. You can control it and say, well, if I change this, how does this happen? So someone does an experiment and they get this awesome result. Does the rest of the scientific community say, oh, yay, wow, you did it, great, look at that? No, they say, I don't know about that. Let me try it. And so they publish articles and they say, this is exactly what I did, and then other people do it themselves. And they either find, yeah, I duplicated that, or sometimes they say, I tried this like 50 times, I followed your directions exactly, and I don't think this is true. And then somebody else says, well, hey, let me try it. And so we're always questioning and wondering and asking questions. The scientific method is what we use to sort of guide all this investigating. And so here's a picture. Pictures are great, a diagram. So the basic steps are observation, hypothesis, and experiment. Observation is where you identify the problem. You're stating the problem and you're collecting data. Data is just information. There's two kinds of data. There's quantitative, involving a quantity. There's numbers involved. And then there's qualitative data, which doesn't involve numbers. It might be a color or a smell or something like that. Excuse me. After we state the problem and collect this information, then we develop a hypothesis. This is a possible explanation. Well, I think this is what's happening. And then we test the hypothesis, and that's where the experiment comes in. You devise an experiment, you say, well, if what I think is going on here is true, then if I do this, that should happen. And so you try it. So like with the pee, it's like, okay, well, there's pee on the floor. Who's doing it? I think it's Andrew. Okay, so what's an experiment we could do to find out if it is Andrew?
Check the different children's laundry.
We could check the different children's laundry, and if Andrew has wet pajama pants, and this has happened, you go to the toilet in the middle of the night, but you don't pull down your pants. It just runs down your legs and makes a big puddle on the floor, and then Mom gets up and steps in it. This is lovely. You could check their pants. Okay, but what if he came in there naked and peed on the floor? Could happen. How else could we check? We could have somebody hide in the shower all day long and watch and see who comes in and pees on the floor. That'd be pretty tedious. Or we could set up a camera or something like that. So there's different experiments that we could do to find out if our hypothesis is correct. So observation, hypothesis, experiment. What if the experiment shows that we're wrong?
If you
We do another experiment. We adjust our hypothesis, and we do another experiment. Okay? Oh, let's see. I need to talk a little bit more here, maybe. I can't remember how all these slides go. What's this other stuff down here? Okay, a theory, and I think there's a better slide on this in a few minutes, but a theory is what we come up with after a hypothesis has been tested. And we think this is true, we've tested it, and that becomes a theory. Lots of different people have tested it, it's a theory. It's a model, it's an explanation of what's going on. From theories, we can predict what will happen in the future, and we tend to keep testing them. So another experiment, and if, sometimes there's technological advances and we find out that, oh wait, that theory that we held for so long, there's this thing we didn't know and now it's not quite true. And so we adjust or modify the theory and then test it again. Laws are slightly different. Laws just state what happens. So here's a little concept check. Which of the steps is missing in this situation? Your instructor's holding a balloon and quickly inhales some of the gas inside the balloon. He then speaks and his voice changes to a high-pitched sound, which sounds pretty funny. He asks you to determine what gas was inside the balloon that he inhaled. Based on your observations, you conclude that the gas must be helium. One of the steps in the scientific method is missing in that paragraph. Which one is it? Did the problem get stated? Yeah, that's the question. The instructor's saying, what is the gas? They didn't perform experiments. Okay, there were observations made. We observed that his voice got high and funny. He didn't die, right? We have a hypothesis. We think it's helium. And part of that is based on our previous experiences, which is also data, but we haven't tested it. So that's what's missing. To test it, you would, there's different ways you could test it, but you could get a tank of helium and fill a balloon and have him do the same thing and see if we get exactly the same result. Does that prove that the gas in the original balloon was helium? No, but it supports that. Interesting thing about scientific experimentation, we can never prove that anything is correct. We can prove that things are incorrect. And so all these things that we hold as scientific facts are actually just things that no one has been able to disprove yet. And so we accept them as fact, but we can't prove things to be true. Interesting idea. So scientific models, we've got laws. A law summarizes what happens. Okay, you've heard of the law of gravity. The law of gravity, it just tells us what happens. If I take this marker and I hold it up and I drop it, it falls to the floor. It does that every semester. Gravity, the law of gravity tells us what happens. Does it tell us why? Nope. Scientists still do not fully understand what gravity is. So a law states what happens. A hypothesis is a possible explanation. We've talked about those. A theory is a set of tested hypotheses. So theories attempt to explain why, and they are tested hypotheses, so they're more advanced than just a simple hypothesis. Anybody can have an hypothesis about anything. But a theory has been tested multiple times by different individuals. And so this gives us an overall explanation of whatever it is that we're looking at.